afternoon, good evening, depending on where you are in the world. My name is Marco Palladino. I'm the CTO and co-founder of Kong. And today we're going to be talking about one of the most important topics that we all have to address as we transform our businesses, and that is connectivity. We live in a digital world. We're seeing this all over around us, and even more so during the current global world situation. Everything really runs on the wire. And if there is any business out there that is not digital yet, it certainly won't exist for much longer. Everything is digital. And at the same time, as we transform and digitalize our business and our applications, our customers and users won't forgive us for poor and broken experiences. In the digital world, being reliable is our requirement. And as we transform and build more and more digital applications, we must always remember that regardless of how we build our software, what technologies we use, at the end of the day, all that matters are the users, are the customers, and their experience. The main driver of pretty much every technology transformation is always the business. We want to grow the business, we want to make existing customers happy, we want to be able to target new customers, we want to be able to capture as much market share as possible. To build a reliable experience in this way, we want to be able to deploy more often. We want to be able to fix bugs as they happen. We want to be agile. We want to be able to make sure that our applications are always reliable and performant. And to do that, we adopt the cloud. We distribute and decouple our software. And then once we do that, we want to be able to scale it depending on the use case, or depending on the traffic that we're experiencing. All of this is being done with the goal of making sure that the experience for the end user is reliable, is fast, is quick, is secure. To do this, we adopt technologies and patterns that can help us achieve these goals. We transition to microservices to innovate and deploy faster, something that was very hard to do in the monolithic world. Large code bases are much harder to contribute to and much harder to deploy, because every time we deploy the entire thing all at once. Whereas with microservices, we can deploy different services that together make up the full experience. We make our software more reliable and deploy it closer to our users by leveraging cloud vendors. Perhaps you even want to leverage multiple of them to make sure that we can take advantage of specific services the clouds are providing us that are cloud specific perhaps, as well as being able to target different regions in order to be able to reduce latency, for example. And we simplify operations by packaging our software in a standardized way via containers and by building on top of very powerful primitives offered by platforms like Kubernetes, for example. These new practices belong to a new era of software that is far away from the previous monolithic one. Companies that have not been able to onboard into this new era, the containerized, the microservice-oriented era, are also the ones that will struggle to succeed against those companies that indeed have managed to make a successful transformation. And really, if we zoom out and we look at the big picture, this new era that we're talking about and that we're seeing all around ourselves didn't start recently, actually. It started half a decade ago in 2013, when Docker was released, in 2014, when Kubernetes was released. Docker and Kubernetes, and the reason why they triggered this new era, these projects provided an out-of-the-box solution to every company that wanted to transform to microservices. Prior to Docker, prior to Kubernetes, some organizations did transform to microservices, but they had to build their own tooling from scratch. With Docker, with Kubernetes, nobody has to build their tooling anymore. It comes for free out of the box from the community. This new era, it's not new anymore. It's really the new default. And again, like I said, it's also an era that's been driven by open source technologies. When we look at Docker, Kubernetes open source. When we look at Prometheus, Grafana open source. When we look at open tracing open source. So open source has been defining this new era. There is no modern infrastructure that is not open source. And in this new era, the more distributed and the more decoupled we become in order to be able to achieve those business goals, and the more connectivity we introduce. By definition, if we decouple our monoliths and we transition those monoliths into services or microservices, we're replacing function calls within the monolith with network calls that connect all of these services together. This generates all sorts of connectivity requirements for our services. Connectivity, it is an enabler to transition to microservices, and it is the backbone of any proper microservice-oriented architecture. Connectivity, it's something that we always had even in the past, but the scale that we have today, it's much bigger than anything else we've ever done in the past because of the transformations we're doing. We can sum up these connectivity requirements by looking at the three main connectivity use cases that we'll have to build in pretty much every product that we create. We have edge connectivity in order to be able to enable external clients or external applications to consume our APIs, mobile applications, partners, a developer community. And to enable that edge communication, we traditionally deployed an API gateway that would be the entry point, the ingress to our infrastructure and to the APIs that we wanted to provide. So we have edge connectivity. Then we have internal cross-application connectivity. So in our organization, there is going to be different lines of businesses, different teams in each line of business, and each one of them is going to be creating applications that other teams may want to consume. The use case, it's very similar to the edge use case from a feature standpoint. In the edge use case, we want to onboard those users, we want to onboard those developers. In the cross-application internal use case, it's quite similar. It still happens the same thing, but it is across teams that belong to the same organizations that we treat as if they were external users. And then, of course, we have the cross-service connectivity. The more decoupled our services become, and the more microservices we introduce, and the more dependencies we introduce. And all of these is connected via service traffic connectivity that has to be managed somehow. And we can adopt service mesh, for example, to manage it. Edge connectivity, internal cross-application connectivity, internal cross-service connectivity. These are just some of the most common connectivity use cases that we're going to be building for pretty much every product we ever create. Now, if we look more closely at these connectivity use cases, we can even go a little bit deeper into what are the specific requirements and dependencies that each one of them brings to the table. For example, for edge connectivity, we are talking about primarily traffic between different applications, perhaps most likely external applications. We want to be able to provide the API and user governance and onboarding to determine who can consume our APIs, how they can consume them, what limits they have when they consume APIs, and what their entire experience is going to look like. An API gateway would be an abstraction layer on top of our APIs. So that the clients that are going to be consuming our APIs in the edge use case, chances are those are not clients, applications that we control, or they're distributed, for example, IoT, in such a way that it makes it very hard to control. So we want to create an abstraction layer at the gateway level that abstracts away our APIs so that we can reshuffle how our APIs are being provided under the hood, and the gateway will keep the compatibility with the external clients. So it's an abstraction layer It provides isolation in a way, because the gateway runs on its own architectural layer, and also provides pretty much zero runtime dependencies. If I'm a client and I want to consume an API, if I go through a gateway, there is no dependency whatsoever, but making the request goes to the gateway. This is different from other connectivity use cases. We're going to take a look into that now. In the cross-application connectivity use case, we're talking about traffic and service traffic across different applications that perhaps are being built by different teams of the same organization. So we still want to be able to apply API and user governance, because we want to be able to determine how different teams are going to be using our APIs, how we can limit them, how we can cut them off if we have to. And so it's the same requirements as the edge use case, but running in an internal setting. So we still have an abstraction layer. So if there is another team consuming the APIs, we don't want them to be exposed to the complexity of all the APIs that we offer, but we want to give them the nice, good-looking API that they will use, while everything else is being kept hidden under these abstraction layer. And again, like the edge use case, API gateways provide isolation and zero runtime dependencies. If I am a team, I want to consume another team's API, I make a request. There is nothing else I need to do but making that request. And then there is the cross-service connectivity. This is traffic between different services that belong to an application. So we build an application. This application is going to be a microservice-oriented application. We're going to be using different services. We're going to be using different dependencies, databases, different, Kafka queues, for example. And we want to be able to secure and observe and manage the low-level traffic that our application is generating across the board, internally. And so we can use service mesh for that in order to be able to delegate our connectivity management away from the services into a sidecar proxy, for example. In this deployment, we have a one-to-one representation of every service. So every service that's part of the mesh can potentially be consumed by every other service, even things that normally would be private. That's why with an API gateway, we're not going to be putting a database behind an API gateway. We're putting an API that abstracts away all the services that are running behind. Whereas in a service mesh, it's a more, let's say, flat world. We can see every service that we're creating and we can consume them all. Then of course we can apply traffic permissions rules and ACL rules, but fundamentally we have a one-to-one representation of the world. And there is a dependency that, unlike the API gateways, we have to introduce. And in this case, it can be a sidecar, and the sidecar needs to be able to access our control plane in order to be able to fetch the right networking and service mesh policies that we want to apply across the board. Now, of course, if we want to enable a service to be consumed by a mobile app or by an external developer, we don't want that mobile app or that external developer to have a sidecar. Sometimes we can't even force them to have a sidecar. And most importantly, we don't want that sidecar, which is outside of our network, to be able to have a connection to the control plane, which is a very sensitive component that should be locked within a restricted network topology. So in some use cases, service mesh, besides the fact that it's a different system, it cannot even be deployed in a capacity that we require when it comes to the edge and to internal. Naturally, in a modern organization with a modern architecture, we're not only going to have one or another connectivity use case, but we're going to be having all of them. It's a full stack connectivity use case that will include all of these connectivity use cases. Every organization in the world is building applications, and these applications are going to be able to consume dependencies internally, and that would be service mesh. They can offer an API to other teams, and that's the internal API gateway use case. And they're going to be also offering some of these APIs externally to, again, mobile developers, partner, or external communities, in order to be able to create an ecosystem and become a platform in the specific use case that we're addressing. It's a full stack end-to-end connectivity that we have to build. Now, when we think about connectivity, connectivity has always been an existing concern, even in the previous era, not in this new era, but the previous one. And back then, like today, the biggest problem And back then we may have had a monolith talking to a database. And back then, like today, the biggest problem of connectivity is the network. The network is unreliable, it's not secure, it's hard to observe. Every time we make a request or we receive a request, the network management features that allow us to control how the service connectivity is being performed across our systems, doesn't come out of the box. We have to manage that service connectivity to make it reliable, make it secure, to be able to log it, to monitor it, to trace it, and so on and so forth. So the application teams traditionally have been managing the service connectivity by writing more code, by doing retries in their code, by, if I'm making a request to a database and that request fails, then we're going to be retrying it, we're going to be logging it. The application teams have been managing the network as they were building their services. Back then this could work because we didn't have much connectivity around. We still had it, but not at the same scale that we're going to be having in this new era. Therefore, the teams were building their code, managing the network, and that was enough back then. But the more services we have, the more connectivity we introduce, and the more fragmentation this is going to be adding to our systems, because different teams are going to be creating and managing the connectivity in different ways. It creates a security risk. It creates a fragmentation risk. And the more services we have in order to scale our business better and win the digital mindshare, the less and less reliable the old methodology of delegating the network management to the application teams is going to scale, because it creates unreliability and security issues. So we know that to be successful, we need to take care of packaging our software, and we use containers for that. We know we need to abstract away the data centers, and we use the cloud for that. We know that we need to abstract away the operations, and we use Kubernetes for that. But to build reliable applications in this new era, we must connect all of their parts together across all of the connectivity use cases. And what do we use for that? Up until now, we use different siloed technologies or methodologies for each use case that we are left integrating with each other to provide the final goal, which is the full stack connectivity that we need. And many, many hours have been spent to get this full stack working in the old era. And quite frankly, it never does. If you are working for an enterprise organization, we know how painful all of this has been when it comes to building modern architectures. In this new era of software, the more decoupled and distributed we become, the more connectivity we introduce. We're going to be having more and more services, and we need something that helps us manage all of these connections, but not in a siloed way, in a unified way, in a full stack way. And that's why we need a service connectivity platform. We need a platform that allows us to manage that service connectivity. It's not one use case or the other. It is all of them together in every product that we build, in every applications that we're going to be releasing moving forward. We don't want to be left alone figuring out how we connect all of this together. When we look at the service connectivity platform, we're really looking at an end-to-end connectivity stack that allows us to abstract away the connectivity the same way Kubernetes abstracts away the data center. Application teams are going to be building their services and focusing on the things that matter, which is the applications themselves, the users, the customers, not managing the network. And all of this comes out of the box. The network comes out of the box with a service connectivity platform that allows us to manage all the different connectivity use cases in a unified and integrated way. It's not service mesh and service mesh only. It's not API gateway and API gateway only. Service mesh, API gateway, cloud native routers are pieces of the same connectivity puzzle. The question I'm asking you is, as we transform and keep innovating, what is going to be abstracting away connectivity from all the teams that are building all of these services so that we don't have to worry about them? The application teams must stop doing connectivity, and connectivity must go back to the right stakeholders within the organization. And that's us, the infrastructure developers and the infrastructure architects that are providing all of this for them for free. The same way we're providing them Kubernetes clusters, we're providing them virtual machines. We also want to provide them out of the box connectivity. There was an enterprise customer that I was working with, a global bank. One of the biggest problems was updating mutual TLS across the entire organization. If you know, a few years back, TLS, there was a specific version of the TLS protocol, I forgot which one, but basically there was a vulnerability and the entire world upgraded to a newer version of TLS. And this global bank, like everybody else, also had to upgrade the mutual TLS protocol. What was supposed to be something simple to do ended up being a multi-year process. They had to go chase down every single team that has ever built any mutual TLS connection in any of their applications to tell them to upgrade in order to be compliant again and secure again. That happened because connectivity was not in the hands of the right stakeholders, which was the infrastructure team. Upgrading mutual TLS with a service connectivity platform would have been a one-click upgrade. Instead, it became a multi-year chasing down all the different teams to work with them to upgrade mutual TLS. And for some of those applications, mutual TLS could not even be upgraded because the clients that were consuming those services did not understand this new version of mutual TLS. You can feel the pain and see how painful it is when the applications teams are doing something that they should not be doing. At Kong, we provide our own implementation of a service connectivity platform. And that is a platform that allows us to decentralize the applications and the services, secure them as we create more and more of them, and then being able to create an internal or external developer platform to be able to address the edge and the internal use case, so that we can secure, protect, encrypt, control all of our services across any cloud or any platform, containers, Kubernetes, virtual machines, that we are deploying across the board. And all of these really, it's built on top of open source foundations. Modern infrastructure is open source. The new default is open source. And the open source foundations that we're using when it comes to our service connectivity platform can be summed up in the following projects: API Gateway, Kong, Service Mesh, Kuma. Kuma, by the way, is a service mesh that is the only donated service mesh to CNCF as a sandbox project that's built on top of Envoy, that's vendor neutral in the CNCF landscape. Very simple to use, very simple to deploy, platform agnostic as well. And then, of course, Insomnia for API testing and design. So we wrap all of these up in such a way that we provide a platform that abstracts away connectivity for the entire organization. And abstracting away connectivity, and the reason why Kong has built this is because every customer we're speaking to that is trying to address this project, this problem, is building their own internally in different ways. And so that's why we provide a turnkey platform that allows to abstract all of that for them out of the box. The importance of a connectivity full stack end-to-end platform is invaluable in this new modern era. So to wrap it up, we're coming at the top of my speech. We have addressed three main topics in this presentation. We're transitioning to a digital world. To transition to a digital world, we want to build reliable applications that can scale and that can get more customers, more users. And as we distribute and decouple them in order to achieve those business goals, we're introducing more and more connectivity. Connectivity is at the backbone of any modern infrastructure. Connectivity up until now has been managed in a very siloed way by the application teams. There is different connectivity use cases we need to take care of: the edge use case, the internal use case, the service mesh use case. And instead of thinking of these concerns as siloed concerns, What we really want is a full stack end-to-end platform that allows us to abstract away all of the connectivity we're going to be introducing in a very simple way. The same way Kubernetes abstracts away the data center, we must abstract away the connectivity. And that's why we need a service connectivity platform. Thank you so much. I encourage you to go on CongHQ.com if you want to learn more about all the things that we're doing when it comes to connectivity. And you can find me online on Twitter at subnet Marco if you have any questions or follow-up. Thank you.